Demuxed. I'm Janet, and today I'm talking about my team's journey to building a live AMA Ask Me Anything video platform. I work with Apollo 350, a small software consulting company that focuses on building video products. Here's the requirements we were tasked with. We needed to build a video conference that could be broadcasted live to thousands of viewers. It was important to have a custom UI and be purely in the browser. We also needed to build a working version pretty quickly. Here's a few examples of the video experiences. On the host side, they can talk to each other in real time. And on the viewer side, they can view the host's videos shaped in circles. Here's the first iteration of the architecture for the platform we built. We needed to leverage existing services in order to build quickly and reliably. At the time, Zoom did not have a customizable UI, but I believe it does now. Jitsi and Ghibli provide an open source solution, but it wasn't as plug and play as we needed for the time we had. Twilio had a limit on the number of people who could be in a room, so we could not put thousands of people in a room to watch. With most services, the industry standard has been to use RTMP for live streams, but unfortunately, this is not natively supported in browsers. We also reduced the scope to only build support for one host and not provide recorded playback automatically. We landed on using Twilio for the real-time video conferencing. It was reliable and easy to implement with. It also allowed us to build a custom UI. We landed on Amp Media to handle the broadcasting and encoding. They provided a one-click AWS WebRTC server that allowed the host to broadcast their video from the browser and encode the video to HLS. They provided a web SDK so we could plug it in and use it. Amp Media also provided a nice monitoring dashboard. We were able to quickly build a prototype of this and see it working in a couple of days. We then put CloudFront in front of the HLS files generated from Amp Media to handle the scale, and we played it with a custom video player using HLS.js. However, we soon found that Amp Media would halt the live stream about 1 out of 15 times. We couldn't find the quick solution to this problem, and we were in a time crunch. We also knew that Amp Media wasn't going to be a long-term solution anyways, because we needed more control over the video encoding in order to support multiple hosts. We also wanted control over the encoding in order to render a custom video level UI. We wanted the videos to be shaped into circles, and we also wanted to animate the dominant speaker. So here's the next iteration of the architecture. We decided to leverage the media recorder API that sent video and audio data over WebSockets to a server with FFmpeg. FFmpeg then encoded the video to HLS. We've had more experience with FFmpeg versus setting up a WebRTC server, so setting up a solution with FFmpeg was a much quicker option for us. This worked pretty well for a few live events, but it still relied on the host's internet connection, which could be unreliable, and we didn't have great fallbacks in place for this. Also at the time, Safari still had Media Recorder as an experimental feature, so we couldn't support Safari for hosts. We also wanted to build the ability to support multiple hosts in the future, and this would make us produce one HLS per host. This was not an option because playing multiple videos on the viewer side has an obvious performance impact. There's also complexity with syncing multiple videos, especially if multiple videos come from a video conference. And iOS Safari doesn't allow multiple videos to play. So here's the latest iteration of the architecture. We talked to Twilio, looked at the Mux blog on the quote unquote the state of going live from a browser, and looked at how Jitsi and Ghibli implemented things. We used a headless Chrome instance that had a quote unquote ghost bot user that joined the host video conference as a participant. We called it the videographer. The videographer is hidden from the host view. The videographer has access to the video and audio tracks for all the participants in the Twilio video conference. From there, we were able to combine all the video tracks necessary into an HTML canvas element where we could customize the animation and styles for the final video. We were then able to combine the canvas video stream with the audio tracks and then leverage our existing media recorder flow to pipe the video and audio to FFmpeg. With this canvas element, we were able to easily style the host videos in circles. We were also able to animate whoever was the dominant speaker using Twilio's dominant speaker detection and request animation frame. I'll dive into a couple of pieces in this architecture. So for the headless Chrome piece, we had logic in place to trigger the start of the videographer about 30 minutes before the event time. This launched a child node process that launched a headless Chrome using Puppeteer. At first, we were hesitant on the reliability here, but we saw 2-3 hour long live streams work without issue. The page, the headless Chrome visits, kicks off the videographer's connection to the Twilio video conference. One gotcha here was that we needed to use Puppeteer to click an element on the page in order to initiate the videographer's work. This was due to the browser restriction of needing a user interaction before media elements could play. For rendering the final video, we kept track of all the video tracks available for broadcasting. We then used request animation frame to update the canvas UI. We would clear the canvas and then redraw the styled video elements. From there, we used the capture stream method to get the canvas's combined media stream. For combining the final audio, we leveraged the audio context API to combine audio tracks into one audio media stream. This allowed us to add and remove audio tracks as participants in the Twilio room connected or disconnected. Here's some other topics I'll speak at a high level. For scaling, we could run multiple events on separate servers, but we could not split up the videographer to multiple servers. We did not see an issue here, and we only supported up to 4 hosts. For error handling, if we had an error with videographer, the child node process, or the headless Chrome, we needed to have logic in place for things to restart, and for FFmpeg to continue outputting video segments where it left off in the existing HLS. For rendering the videos in circles, we did not make it complicated here. We simply centered the video into a circle and hard-coded the location of the circle within the video, depending on the situation. For moderated questions, we had to show viewers the currently selected question a host was answering. There's complicated solutions to make this work, but we simply added a hard-coded delay from the moment a host selected a question to when the viewer saw the question selected. This delay was an estimated time that included the videographer, the encoding time, and the player live playback buffer. We found that this was a good enough user experience for the resources and time we had. We ended up using an 8-second delay. For recorded video, since we had access to all the HLS files from the live stream, we could easily convert that to a VOD version using FFmpeg. So thank you for listening. Hope this was helpful for someone, and feel free to reach out to me directly if you have any questions. Thank you.